Hey kiddos, I hope you are ready for the Unit 5 practice test. I'm going to go ahead and share my screen and we're going to get started. What I am doing right now is recording videos for you to watch and take notes from to prepare for your Unit 5 test. In order to be prepared for what you are about to do, you need to make sure you have paper and pencil and a calculator. You are welcome to use the Desmos calculator to help you on all of these problems. The link for the Desmos calculator is in It's Learning on your math tile. You want to make sure you give yourself about an hour to watch all the videos and to take notes. The more notes you take, the better prepared you will be for the actual unit test. You also want to make sure that as I am going over these practice test questions with you, that you are either circling or highlighting or somehow flagging the questions that you still don't understand, even after I have gone over them and taught you how to do them. If you still don't understand how to do that problem or know that there's no way that you'd be able to be successful on a problem just like that all by yourself, you want to make sure you mark that somehow on your paper so that the next time we meet in a live Zoom session, I can give you another sample question that's similar to it to make sure you can do it, or I can go over how to do that problem with you again in another session. Okay, so take a minute to pause this video and get yourselves organized. Get ready to take some really good notes. And you might need, like I said, a couple of different colors to write things down in. So I'm going to go ahead and get started. This is, again, Unit 5 practice test. The first question on the practice test says, Sammy is the manager of a mall. He is estimating the number of people that shop in his mall that like to eat in the food court. He needs to create a random sample of people. How should Sammy collect his sample? So, ladies and gentlemen, let us remember what a random sample is. A random sample is something that is done that takes a small random piece of the entire population. And we do that in order to represent the entire population. And we want to make sure that each member has an equal opportunity of being chosen. So what we're really trying to do here is to eliminate any answer choice that shows any kind of bias. And remember, the word bias basically means that you would be more likely to choose one answer over another. So a perfect example would be if someone were to come and ask me what I thought about what I'd want to watch on a weekend, and they were trying to get a random sample, I'm going to always choose something athletic to watch. I love watching sports on TV, so I would be considered a biased sample because I'm always going to choose one category over all the other categories. Okay, so we really want to look for answers that eliminate any biases. So let's go through this again. Sammy is the manager of a mall. He's trying to figure out the number of people that when they shop in his mall, they want to eat in the food court. And so he's trying to figure out how to collect a random sample. Answer choice A says that Sammy should ask the first 50 women that come to the mall if they like to eat in the food court. All right, I'm just going to read through these answer choices. And as I read them, I want you to think about whether you hear anything that might cause bias or might be specific to a single group of people rather than an entire random sampling of people. Answer choice B, Sammy should ask any 50 customers that go to the mall if they like to eat in the food court. Answer choice C, Sammy should ask 50 employees in the mall if they like to eat in the food court. And answer choice D says Sammy should visit a Chick-fil-A and ask 50 customers if they like to eat at the food court in the mall. All right, so if you go back up and look through those answer choices, there is only one that does not have any bias to it at all. Okay, that it's really wide open for any kind of responses that people are going to give. So I'm going to direct your attention to a couple that have biases, and I'm going to explain why they're biased. Answer choice A is incorrect. It is biased because it is only surveying women. All right, you cannot just take a specific gender and only survey them. for whatever reason, maybe women would be more likely to choose to eat in the food court. Maybe they would be less likely to choose to eat in the food court. But we are eliminating all of the male type of response that we could get. And because of that, we call this biased. And so this would not be the best way to collect a sample. Another answer choice that is biased would be asking employees, all right? 50 employees in the mall if they like to eat in the food court. I want you to think about why you think that might be biased. So if you're an employee at the mall and you're at work, let's say you work at PacSun and you need to take a 30-minute break to go and eat, you are almost always going to go and eat in the food court because it is convenient, it is close by, and it would take less time. So if you only interviewed or surveyed your employees in the mall, you are going to get what we call a skewed result. All right, your answer will be skewed because it is surveying only a specific group of people who are going to be much more likely to eat in the food court than any other group of people. So it cannot be answer choice C. So we are now between answer choice B and answer choice D. And hopefully just by reading through those two choices, you could see that you don't want to just go to the Chick-fil-A and ask 50 customers if they like eating at the food court mall because Chick-fil-A is in the food court mall. So you are asking people that are already likely to eat in the food court if they like eating in the food court. So again, this is skewed because asking people who work at Chick-fil-A would be biased. Okay, so it can't be answer choice D. So it would have to be answer choice B because he's just asking any random customer that came into the mall. Some of those customers are there just to pick up one thing at a store and leave. Some of those customers are to hang out at the mall all day, but maybe they would prefer not to eat in the food court because they don't like the food there. You're getting a really random sample. You have no bias in just 50 random customers that walk through the mall's doors. So choice B is the best way out of these four choices to collect this sample. Okay, take down whatever notes you need to take down from that one. And I'm going to move on to answer choice or question number 2. Remember, you can always pause the videos as I am moving along quickly to get down what you need to. All right, going on to question number 2. Question 2 says, read the survey described below. An online survey of 1,500 randomly selected teenagers from across the county, show 3 of 4 teenagers actively engage in social media. Which 2 statements are true? I'm going to read the question again. It says an online survey of 1,500 randomly selected teenagers from across the county showed 3 out of 4 teenagers actively engage in social media. And they want you to select 2 statements that are true. All right, so the first piece of information I really want to draw your attention to is this word right here, randomly selected, or these 2 words, randomly selected. Okay, so out of all of the teenagers in the county, so out of all of those teenagers that are in the county, and I don't know how many there are lots of them. There is a small group of that entire population that we are calling the random sample. All right, and that random sample contains 1,500 teenagers. All right, so maybe in this particular county, let's just say there are, I don't know, let's just say 40,000 teenagers or something like that. We're not given this number, but we can kind of make an idea or a generalization in our head that that number is going to be pretty large. And out of however big the number of teenagers in the county are, they did a random sample, and that random sample contained 1,500 teenagers. Okay. And they're asking us to, from these answer choices, to pick 2 statements that are true. So this is really a vocabulary question, all right? I'm going to tell you right now that the population, we don't know. It doesn't give us that information. I made it up. I said, well, what if the population were 40,000? But the population is your entire amount of people. The random sample is a very small piece of that entire population, okay? So I'm going to read choice A. It says the population of the survey was 1,500. That is incorrect. That word should have been random sample, and it's not, so that one is incorrect. The population was not given. We don't know how big it was. Answer choice B says the population of the survey was teenagers across the county. So is that who was interviewed? Is that who was asked? And that is correct. It says an online survey of 1,500 randomly selected teenagers from across the county. All right, so the population that they were targeting was teenagers across the county. So I think this is a correct answer. I'm going to kind of keep B in the back of my head. Excuse me. Answer choice C. The population of the survey was 4 teenagers. Well, that wouldn't make any sense. If the entire population was 4 people, then the random sample, the sample set would not be 1,500. That can't be right. The answer choice D says the sample of the survey was 1,500 teenagers. That's exactly what I've written right here. So I know for a fact that answer choice D is correct. And then finally, answer choice E says the sample of the survey was 3 teenagers. So here's a thing that you might get mixed up on. In this particular question, it says 3 out of 4 teenagers, right? So 3 out of 4 teenagers are on social media, but that's not what this statement is saying. This statement is saying that the sample size was 3 teenagers, and we know that's incorrect. We know the sample size was 1,500, so it cannot possibly be choice E. So therefore, the 2 correct answers are B and D. Right, for this one, when you're copying down notes, you don't want to just copy down B and D. That doesn't mean that the answers on the actual test are going to be B and D. What you want to copy down are notes, information that's going to help you remember what the difference is between a random sample, an overall population, right? And maybe anything else that you heard me say that was really important as I went through those answer choices. So take a minute to pause the video, copy down what you want. I'm going to move on to question 3. All right, question number 3. Mr. Stanley is a gardener at a local nursery and would like to add a new plant for his customers. He decides to conduct a survey in order to help him make a decision about what type of plant to add. Which of the following sampling techniques should Mr. Stanley use in order to obtain the most representative sample of survey respondents? This question is extremely similar to question number 1. We just talked about this. The things we want to be looking out for are bias and skewing our answer set, right? We want to make sure that the people who Mr. Stanley questioned are not biased and they represent the entire population. So we want to be crossing out anything that shows bias, okay? So let's read through the answer choices and see what we can see. Answer choice A, Mr. Stanley should ask one group of shoppers at his morning that come in the morning. I rewrote this question poorly. I apologize. Let's try this again. Mr. Stanley should ask one group of shoppers that come in the morning. Sorry about that, guys. Mr. Stanley should ask one group of shoppers that come in the morning and one group of shoppers that come in the evening. I don't really see anything very biased about that. It doesn't really give me a number, just as a group. It's not very specific. It's not telling me who he's asking or how many of them he's asking. This could be right. I'm not really sure. So I'm going to skip it for now and I'm going to go on to the next one. Choice B says, Mr. Stanley should ask at least 75 randomly chosen guests at the nursery over the course of the week. Again, I'm not really sure about this one. I like that he's asking 75 randomly chosen guests. That is not biased. I don't know. He's only asking the people that come to the nursery. But then again, only people who are coming to the nursery are going to be buying whatever plants he chooses. So I don't know that this necessarily is going to influence anything. This might still be okay, although maybe it shows a little bias. I'm not sure. So I'm still going to say I'm not sure. I do like answer choice B more than answer choice A. All right, just because it gives me a number. And it kind of gives me a little bit more specific information. Let's see if we can eliminate one of these. Answer choice C says Mr. Stanley should ask all the women who visit the nursery over the next week. Well, women is biased. We cannot just pick a specific group of people. So I'm going to say it cannot be this one because it just talks about the women. And then Mr. Stanley for choice D should ask all the guests at the nursery who purchase rose bushes. Well, if I'm trying to figure out what kind of new plant I want to allow my customers to choose, and I'm trying to get a random sample, I'm not going to pick those people who only buy rose bushes, because for sure they're going to pick a plant that's either similar to a rose bush or maybe a different variety of rose bushes. So the fact that they include rose bushes shows bias, and so I'm not going to include that. All right, so I know it can't be C or D. Now I'm back to A or B. So I'm trying to figure out, I'm going to reread the question and see if I can really focus my attention. It says, which of the following sampling techniques should Mr. Stanley use in order to obtain the most representative sample of survey respondents? Well, honestly, guys, I don't like the question that I wrote, but I wrote it almost exactly the same as the actual test question. And I think I did this on purpose, because I think in this case, it really could be either one of these. It really could be A or it really could be B, because these are both not really biased. I know some of you might say, well, if they're only asking people at the nursery, that's biased. However, again, he's conducting a survey about his customers. So I guess they kind of have to be at the nursery. So I'm going to remove that as a bias. All right, so one group of shoppers that come in the morning and one group of shoppers that come in the evening, that's really a wide variety of people. He's not saying male or female. He's not saying a specific group that likes a specific flower. So I think that's pretty random. And Mr. Stanley asking at least 75 randomly chosen guests. Well, they're specifically using the word random here. So again, kind of a strange question. I'm going to go with B because it says randomly selected. Right? It says, which should he use to obtain the most representative sample? Well, he's going to pick 75 random guests and ask them what they think. So I'm going to go with B. I think B is the better answer out of those two. Even though answer A is okay, I think answer B is definitely stronger. All right, moving on to question 4. We're going to eventually start doing some math here, people. So we just haven't gotten there yet. We've been talking a lot about sample spaces and populations. Let's see. Question 4 says Trevor has 5 siblings. He wants to find out how many of the 500 7th graders at his school also have exactly 5 siblings. Which is the best method for him to use? So again, another question about how to obtain a random sample. All right, so we're trying to figure out which ones show bias. And we're going to read our answer choices. Answer A says he should survey 50 students who have more than 2 bedrooms in their house. I think that you already know how to feel about that one. If you have more than 2 bedrooms in your house, it probably means you have a bigger family, right? People who have more than 2 bedrooms oftentimes have more than 1 child. So this might show bias. I'm already saying I don't like this. Answer choice B says survey 50 students randomly selected from a PE class. Well, PE class, I don't know. Why would that make a difference? I don't know if that's random. It says they're randomly selected from the PE class, but I'm not sure if that's going to make it biased or not. Let me keep reading. Answer choice C says survey 50 students that Trevor knows have siblings. Well, that's a specific group. That's definitely showing bias. Okay, so because he knows these kids, these other students have siblings, he's already eliminating the group of people that may not have siblings. And so that's already showing bias. So it cannot be C. And finally, answer choice D says survey 50 students randomly selected from a list of all 7th graders. Well, I like that one better than the ones randomly selected from a PE class. All right. It's not that the results are necessarily going to be skewed up here, right? I don't know that people who take PE are any more or less likely to have siblings, but it's still not representative of the entire population. It's only representative of those kids who happen to be in PE class. So because of that, I'm going to eliminate choice B because I do think it's biased. It's only pulling from a certain part of the population. And I'm also going to eliminate choice A because it's only pulling from a certain part of the population, right? This population has more than 2 bedrooms in their house. So I'm eliminating a whole bunch of other people that may not have more than 2 bedrooms in their house. Just because you have more than 2 bedrooms, that's not the only way that you can have 5 siblings. You can still have 5 siblings and still have a 2-bedroom house. So, or a 1-bedroom apartment for that matter. So I'm going to eliminate that one because it is not the best method. So answer choice D is the best way. He's going to randomly select 50 students out of all of the different 7th graders that attend his school. All right, hopefully you are getting a little better handle on how to get your random samples. I'm going to go on to question 5. Question 5 is a drag in the blank question. It looks like it's true or false. And it says the principal of a middle school wants to know if the students in his school prefer having a middle school dance or a Chick-fil-A party as a school-wide reward for good behavior. He surveyed 5 groups of each grade level in the school. And there are 3 grade levels, 6th grade, 7th grade, and 8th grade. So he surveyed 5 groups in 6th grade, 5 groups in 7th grade, and 5 groups in 8th grade. Each of those groups contained 20 students. At the end of the survey, he learned that a total of 120 students preferred eating Chick-fil-A over selecting the school dance. Using the information gathered, determine whether each statement is true, drag true or false to each blank. Each response can be used more than once. Okay, so we got a lot of information going on here. First of all, we've got to deal with how many people we're talking about. And so the first thing I'm going to do is I'm going to start by writing down some information I know. I know that I have 5 groups that are being surveyed, right? And I know that there are 3 grade levels that are being surveyed. And finally, I also know, I guess I should be saying and there are 20 students in each group that are being asked. Okay, so I can look at this a couple of ways. I can start by saying, okay, well, I've got 3 different grade levels. I've got my 6th grade level, I've got my 7th grade level, and I've got my 8th grade level, right? Maybe we could just group it like that. Okay, so for 6th grade, I have 5 groups. And for 7th grade, I have 5 groups. And for 8th grade, I have 5 groups. All right, and each group contains 20 students, right? So each of these groups has 20 kids in them that they're surveying. All right, so I could do this through all the circles and get a total number of kiddos that were surveyed. All right, there's a faster way of doing this. This is called a repeated addition, right? If I add 20 plus 20 plus 20 all these times. A faster way to do this is to count out how many circles have 20 in it, right? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've got 15 groups of 20 students. All right, so I could find out my total number of students by multiplying. I could do 15 times 20. And again, that's what your calculator is for. I'm going to actually just do the math, but you could use your calculator. And when I add them together, I get 300. All right, so what does this mean? This means that out of all of the kiddos in this middle school, they surveyed 300 of them. They surveyed 300 total kids. All right, so that would be 100 from each grade level, 100 in 6th grade, 100 in 7th grade, and 100 in 8th grade. So the principal went around, he randomly selected 100 kids from each grade level, he surveyed them, and then he learned some information about what he surveyed. Okay, this is what he learned. I'm now going to give you that piece. At the end of the day, he surveyed 300 total kids, and he learned that 120 of those kids preferred eating Chick-fil-A. So what I can do is I can write a fraction that compares the number of kids that like Chick-fil-A I'm going to call it CFA, Chick-fil-A, out of the total number of kids that were randomly selected, right? Not out of the entire population. He's only talking about of those 300 kiddos that he surveyed, 120 of them preferred Chick-fil-A. So I could create a fraction that compares those two numbers. So the number of kids that like Chick-fil-A was 120, and then total number of kids randomly selected, remember, was 300. So there's my fraction that represents that information. That is going to become extremely important in answering my true or false questions. Okay, now remember, we could do a couple of things to this fraction. We could divide 120 by 300 and get a decimal. We could turn this fraction into a percent. And so it just kind of depends on what the questions ask. So let's look at answer choice A, or question A. It says Chick-fil-A was preferred by 50% of the students. All right, so I am going to say what I'm gonna need to do. First of all, I'm gonna make a little bit of extra room. So again, now is a great time to pause the video and copy down what you want off of this screen. I'm going to remove some of this information, and I'm going to give myself a little bit more space to do some math. Okay, so what I'm going to do now is I'm trying to figure out if that fraction that I wrote, that 120 out of 300, has anything to do with 50%. All right, so I'm going to do it this way. I'm going to take that 120 out of 300, and I want to turn it into a percent. And remember, to turn a fraction into a percent, we divide, right? That's what the fraction bar means. We're going to divide top number by the bottom number. Okay, so I'm going to use my calculator. And I'm going to do 120 divided by 300. And I get a decimal. Okay, so 120 divided by 300 is 0.4. Okay, so that's not a percent. I now need to take this decimal and I need to convert it into a percent. So I'm going to turn it into a percent by multiplying it, do you know? Multiplying it by 100. Percents are always out of 100. That's why we multiply by 100. All right, so I'm going to multiply 0.4 times 100, and I'm going to get whatever I get. And if I did that on my calculator, I would get 40. That is my percent. So what this fraction represents, this 120 out of 300 kids, represents 40% of the kids that were surveyed. 40% of them said that they prefer Chick-fil-A. All right, now the first question says Chick-fil-A was preferred by 50% of the students. I'm calling that false. That's 40%, not 50%. That's a big difference. Okay, so answer choice A is false. Ladies and gents, just as a side note, you can instead, if you don't want to do this two-step process to turn this fraction into a percent, you could have also done 120 over 300 equals X over 100. This is another way to get to the percent. Percents are always out of 100. That's why my denominator is 100. This is called a proportion. We learned how to do this earlier this year, right? And so if I wanted to find out what X is, what I could do is use cross products, right? I could take 100 times 120, and I could set it equal to 300 times X. And I could do the math and solve that equation to get my answer. I would get 40. I would get that X equals 40, and that would be your percent. You're going to get the same thing. It's just a different way to look at it. Okay, again, if you like that method better, I probably should have shown cross products. Okay, if you like that method better, pause the video, go ahead and copy that part down. All right, let's look at question 2. Question 2 said an average of 8 students in each group prefer getting Chick-fil-A, right? So here's how I would approach this one. I know, I'm going to clear all this except for the false and the 120 out of 300. That might come into play. I want to keep that. That's an important fraction for all of this. Okay, and we'll remember what that fraction represents. I'll actually keep it over there. Okay, so question B says an average of 8 students in each group prefer getting Chick-fil-A. So they are saying 8 students in the group. In the group of what? He surveyed 5 groups, right? Each group having 20 students in it. So this is really trying to figure out if this 8 students represents the total number of people within the group that like Chick-fil-A. So this is, I think, the way I would approach it. There are lots of different ways to think about doing this problem, but what I'm going to do is I'm going to say, well, I know that 120 out of 300 kids that were randomly selected liked Chick-fil-A, right? So what I could do is say, is this the same as 8 out of my total number of people that I surveyed, which was 20 per group? So I could say, are these 2 fractions equal? That's one way that I could do it. I could also say that I remember that 120 out of 300 is 40%, right? And so another way that I could answer this question is by figuring out is, or I guess I should say not is, what is 40% of the 20 people in each group? All right, because this fraction represented the 40%. This is 40%. So I could figure out, is this fraction, is this 40% of the 20 people in the group the same as 8 students? All right, so it kind of depends on what you guys, how you guys want to approach the math problem. I'm going to show you how to do both of them. This one says, what is 40% of 20? 40% written as a decimal. Remember, we're going to now take it out of percent form and put it into decimal form. So we move the decimal point 2 places to the left, which is the same as dividing by 100, right? And we would get 0.40. Of means to multiply. And 0.40 times 20 is whatever it is. I'd punch that into the calculator and it gives me 8. That number looks familiar. All right, so what is this saying? That means if I only had a total of 20 students instead of 300, 8 of them would prefer Chick-fil-A, just like the 120 preferred Chick-fil-A. So this statement is true. I have just proved it. All right, I'm going to now show you how to answer that question using this other method, okay? So I am now going to look at this fraction, this proportion that I've set up. And remember, this is comparing the number of students that like Chick-fil-A to the total number of randomly selected students. And I'm trying to figure out, is 8 the right number out of the 20 people in each group? That's where I came up with that fraction. To figure out if these 2 fractions are equal, there are 3 different things I could do. The easiest, in my opinion, is cross products, because it's what you're used to and what we keep reviewing. So I'm going to do 120 times 20 And I'm going to see, is that the same as 300 times 8? All right, so I'm going to use my calculator. 120 times 20 is 2,400. And 300 times 8 is also 2,400. So this statement down here proves that 8 is the correct number out of 20 that prefer Chick-fil-A. So because this gave me a true statement, this answer up here is true. Okay, guys, this is a DOK 3. If you're getting a little bit lost in the confusion, there's a reason for it. This is a hard question. There are lots of pieces to this. Finally, question 3 says, if the principal surveys 30 groups, remember we had originally surveyed 5 groups. If he now surveys 30 groups, he should expect to find 240 students who prefer to have a dance, right? So I am going to try and do the math for this one. I want to remind you that there are 30 groups, right? And in each group, there are 20 students. Now, I'm not going to draw out 30 groups, but you can imagine if I drew out 30 groups and I put 20 students in each group, the fastest way to get this total amount of students would be to multiply, right? So I first need to figure out the total number of people, all right? So I'm going to do 30 times 20, and I get 600. Okay, that's step 1. All right, I'm going to erase all this other stuff. So again, if you're taking down notes, you're writing down step 1 is to figure out how many total kids have been surveyed, right? In this case, it's 30 groups, and in each group there are 20 students. So to find out the total number of kids surveyed, I do 30 times 20. All right, so now I know that there are 600 total kids surveyed instead of this 300. Right, it then says, should he expect to find 240 students who prefer to have dance? All right, well, I don't have a number of kids that prefer to have dance, right? What I have in this problem was a number of students who prefer Chick-fil-A out of 300, right? So here's what I'm going to do. If there are 300 total students surveyed, and 120 of them prefer Chick-fil-A, to find out how many of them prefer dance, the dance, I'm going to subtract. 0 minus 0 is 0. 10 minus 2 is 8. 2 minus 1 is 1. So I could create a different fraction that compares the number of kids that want to dance or to have a dance. I can compare that to my total number of randomly selected kids. Okay, and so in this case, it would be 180 kids liked to dance out of the 300 that were originally surveyed. All right, so there's my new fraction, 180 out of 300. All right, and so they're saying if he surveys 30 groups next week, should he expect to find 240 students who prefer to have a dance? Well, that's not what we found, right? We found 180, but it wasn't out of the 30 groups. So what we need to do is we need to take this 180 kids who prefer dance out of the 300 originally surveyed, and we now need to adjust this fraction to pretend that instead we now have 600 total students, right? Because it then says he surveyed 30 groups. Okay, so I don't want only 300 students in the group. I want 600 students in the group. Okay, so I have 2 choices on how to solve this. I can use those cross products and solve the equation, which I think is harder for you guys. So I am going to show you the easier way. I'm going to say, how do I get from 300 to 600? Well, how do I get from 3 to 6? I times it by 2. So to get from 300 to 600, I times it by 2. And whatever I do to the bottom, I do to the top. And 180 times 2, 2 times 8 is 16, carry the 1, 2 times 1 is 2, plus 1 is 3, is 360. All right, so what did we just find out? Phew, that was a lot of work. We just found out that if I surveyed 600 students, I should expect that 360 of them would have preferred to have the dance. And in this particular question, question number 3, it says that 240 students would prefer to have the dance, which is false. All right, kiddos, all of the notes you need to take from this slide should take you at least 10 minutes to watch. Maybe you need to watch it 2 or 3 times. You need to make sure you got it all copied down and that it makes sense to you. All right, this is literally like having 3 different test questions wrapped into one. And so you need to make sure that if all of these numbers were changed, that you would be able to answer a question that's similar to it. DOK 3 for sure. This might even stretch over to DOK 4.